So just let me know when you, there you go. Okay. All right. Oh, you know what? I need to share my screen. Where is that in Zoom? Not there. I am completely lost as to, oh, there's a big share button. Never mind.
Arrow at the bottom on
Yeah,
Zoom
yeah,
or
no, it was right in the middle, nice and big, and I just completely missed it. Okay, so I'll just do my full desktop. Okay. Um, allow. You guys can see? We're good.
right
Okay.
browser?
All right. Oh, I have this. Can I get rid of that? And uh, can I get rid of this this Zoom meeting bar? It's like right over my URL bar. Go away.
And move it. We'll be able to click and drag it somewhere.
Oh,
Yeah,
well,
we can't
can I just
actually
like,
see it,
can I
so
put it in my trash bin?
it's just in your way.
Go away. Can you put this in the background by any chance? This thing is so annoying.
Forget what the option is, but I think one of the settings you can move it to either like the bottom or the top or either end.
Hide,
Yeah,
hide
there's like
floating
a
meeting controls. There we go. Okay, figured it out. I am a software developer. Okay, so LiveView Native, I don't have slides, but I'm going to take you through building a project. And I think when I had originally proposed this to Micah, I don't know what, 3 months ago, a while back. The idea was to actually run a workshop, and the reasons why we've stopped running the workshops in part is because uh, they require Xcode, and then what ends up happening is that it doesn't matter. Like, I'm not like saying this crowd wouldn't, but whenever we have a workshop, you give them instructions, and then people always show up without, it's like MacBook. Someone shows up with a Windows laptop. You say install Xcode, latest version of Xcode, have these simulators installed. Someone doesn't have that, and Xcode simulators are gigabytes and gigabytes of size. So it hasn't been a smooth experience on trying to make sure everyone's dev environments are set up for these workshops. Instead, what we've been working on is this little kind of side app called LVN Go, which I'm going to show off in a little bit. Um, but I'm going to take you through the process of two applications. The first is I'm going to create a brand new Phoenix app, add LiveView Native to it, and then quickly like just show you how fast it can be going from a like Phoenix new to having a native application that's interactive and stood up within just a few minutes. So I'm going to go here and I'm going to do mix pjx new. I'll call it demo 2 because already have a demo. I'll just do no ecto. So noted dependencies because I'm going to have to install more. And if anything's too small, just let me know. So first thing I'll do is in my mix file here, I'm going to add, uh, we're going to work off of the current release version of LiveView Native. There are some bugs in it that I'll point out specifically around some navigation stuff. We've been working on improving these UI interactions. If people follow me on Twitter, which is always a bad idea, but if people happen to follow me on Twitter or Blue Sky or whatever one we're going to be moving to in a month or so, um, I put out some videos, I think yesterday or the day before, showing some navigation improvements, and I have those videos I can show off in a little bit, just like the before and after of what the current state of the released version of navigation is, and then where we've been able to achieve, just to demonstrate that we are focused on quality, we are focused on making it as close to a native or identical to a native experience as we can possibly get, and I think that we've been able to achieve that by and large. So the current release version is 0.31. Oh, what the hell? Why did that come back? Oh, wait. Is that going to happen every time I hit escape? Oh, god damn, I can't use my Vim. I can't use my Vim bindings. All right. Can I just like move this? Oh, it doesn't even let me get it off the screen. Go away. I'll put it down there. All right. That's about as out of the way I can get it. So there's four libraries that we'll be installing. LiveView Native, LiveView Native Swift UI, LiveView Native style sheet, and then LiveView Native live form. And I'll be going over what style sheet and live form are. LiveView Native it handles all the server side aspects of LiveView, getting LiveView to respond to LiveView Native. And this is necessary for a couple of reasons. Primarily because LiveView itself was hard coded and still is hard coded for HTML. I've been advocating for a while now to undo this, but have not had any success, unfortunately. The the clients themselves, we are responding to and emitting specific content types. So in the case of SwiftUI, we define a new one. The content type text slash SwiftUI. Jetpack will be text slash Jetpack, WinUI3, so on and so forth. And so when we have the clients connect, we have to make a content type request to ensure that it is responding with the correct content type. This allows us to repurpose the live views themselves, and then do what we call render delegation to our, format delegation to our render components. All right, so now all the dependencies are in. We're going to run mix lvn.setup, and this is going to tell us right away after a compilation. Let me make this a little bit bigger. I apologize if you hear things in the background. It's, coming up. It's the witching hour at my house with the kids. I use the mixer on my microphone to try to drop out the voice frequency. So we'll see how successful it is. All right. So after you run mix LVN setup, all that's really going to do is give you instructions on what you should be doing to set up your application. Mix LVN setup.config. This is going to step you through in actually making changes to your app. So here we're given a process we can step through and say yes, no to things. We can get a diff, and we get a nice diff that's going to be changing here to our config.exs. This sets up LiveView Native in several different ways. The first of which is we're adding the template engine. In this case, we are using HTML engine, just because the format encoder is identical in terms of what we're outputting. We could have just redefined this, but we'd just be delegating off. We're setting up the proper MIME types, and we have a styles for our style sheet MIME type, and then we have SwiftUI. We are setting up our plugins for LiveView Native, the template engine, which is different than the format encoder. And finally, this is setting up our style sheets. So we're going to say yes to this, and then the rest of them are pretty basic differences. You can go through it yourself if you're curious. Now we are going to run the second command. It tells us not to forget right here, mix lvn setup.gen. This is going to generate a bunch of things into our application. And I'll go through each of those. The biggest ones to notice right away are that in addition, this is our web module, right, that you're all accustomed to in your Phoenix applications, and we now have a native module, which is providing very similar, well, you're going to use it in practically the same way. So in a live view itself, you're going to say use my app native. In this case, it'll be demo 2 web native, and then just live view. And then it has helper functions to set up components, render components, and so on. In addition to that, a styles directory is added, and this is where you're going to be defining actual styling for your application. Similar to Tailwind, we use the same process for scanning your application for words, and then we pass it through our style sheet compiler, and then it emits out a compiled style sheet. Instead of having it in our assets directory, though, we make it an actual Elixir module. This allows us to take advantage of live reload very easily. Whenever any changes, this module here is going to watch any file in your application that matches a particular pattern. In this case, any files that have a SwiftUI segment in their file name. And when those files change, it will, upon the next request that comes in, the code reloader will automatically recompile this style sheet module and then after compilation, it emits out a style sheet artifact. We also get a core components file. So just like your regular like web core components, the SwiftUI core components have the identical function names. So you have inputs. In this case, it is particular that the type value is going to be different because this reflects back a like picker is a SwiftUI view, multi-date picker, SwiftUI view, and so on. But for example, if you were to go look at the modal function, the modal function that we implemented is identical in name and argument types as the web one. So the idea there is that while having to absorb SwiftUI as a new UI framework and all the modifiers and such is a lot of work, we want to push people in the direction of normalizing on the function components so that you have your web function components, you have your SwiftUI function components, you have your Jetpack function components. So a common language begins to develop at that point where it's going to be more performant to write the function components than to write just the markup itself. The complexity with the markup is such that it's kind of like having to go relearn HTML, CSS to a degree. We do have a potential where we can optimize this. We can abstract this away in the future with a common UI framework, but right now we're at the phase of ensuring that doing the markup itself is as effective a means as possible for reproducing and be able to access everything that you would otherwise access if you were writing straight SwiftUI. You also get a layouts, and in here you get an app and root files, just like on the web. So the idea that we've been trying to lean into is that in every case possible, we want to repurpose your familiarity with building applications with LiveView already, meaning that we are leaning into the programming model and the way that you are accustomed to building UI presentations on the web. We're going to be steal as much as that as possible so that your experience of building applications isn't that much relearning. Like as far as event handling, application, like the application organization, we're going to find things, what you need to do with it, state management, all that is identical to LiveView. The differences are going to be, again, the markup and the styling. All right, so it created this native directory. So we'll open this in a minute. This is going to be your Xcode project that it already pre-generated for you, and it's all set up and ready to go. Just as long as you're got all your simulators installed, and then the compilation, of course, is always a fun time on Xcode. So what we're going to do now is I'm going to open the router, and we're going to add a live view. So we'll just do live here, and let's do home live, and then we're going to add a new live directory, and we'll add home live.ex. Is my language server going to work? No. All right. So language server is not working. Demo to web dot home live do here. All right. So use demo to now it's working. Live view. So I can show doing like a web, the web side of it too. Not super interesting because it's not really what we're targeting, but we do have to define the render function for the web regardless, even if you don't intend to use it, just because the like live view requires the render function to be defined. So we're just gonna make it empty. And we'll do a mount. And we'll do okay. Signs, and we'll just do count 1. Oh, count 0. All right. Close duple. All right. What's it complaining about? Hold on, since there's an error. I think there's actually an error. Maybe because socket here, not signs. All right, so now we're going to generate a LiveView Native render component, and I'll explain what that is after I've generated it. lvngen.live, and we're going to give it the format, in this case, SwiftUI, and we'll just say home. So what ends up happening is when the client connects, it actually comes through this LiveView here, and there's an on-mount callback. The on-mount callback delegates to what we're calling the content negotiator. Based upon the format of the inbound request, in this case, the format's going to be SwiftUI because the content type is text SwiftUI. It will then say, instead of using this render function, it's going to know to delegate the render function to this module instead. So down here, we're going to define our own render function, and we give it 2 arguments instead of 1. The reason for 2 arguments is we have a render1 function that's already defined within this module. The interface, which is the second argument, is it's a map that comes in from the client, and it's going to include a lot of information about the client. It's going to include its target, which could, like in the case of SwiftUI, could be iOS, iPadOS, watchOS, tvOS, visionOS, macOS. It will include orientation. It will include application version. It will include the client operating system version. So there's different things that you may want to pattern match upon in order to render the proper template for the given device that's connecting. And instead of the H sigil, you're going to use LVN. This now allows us to actually create our LiveView Native template. So in here, we're going to do a text view, and this is the same as the SwiftUI text view. It's just identical. So any SwiftUI views that exist here, like off of like these views in here, as long as they're SwiftUI views, you know that whatever it's called, that exists in LiveView Native. We're just accessing it directly. The arguments that you end up passing into, and I'm just see if I can find one with arguments in it. So maybe like tables. And we got a table here. And we see table mate. Okay, so like value, like these are going to be attributes on the element in the markup. So argument. So the name of the struct, name of the view in SwiftUI becomes the tag name. Same casing. The name of the arguments become the attributes in the element. Same casing. And then we actually do type coercion because everything comes in as a string from the in the template. And so within LiveView Native, we know what type it's supposed to be, and we just do a type coercion off of the string. So I'll say, hi, JaxEx. All right, pretty simple, right? Let's run server now. And we can see that in this case, this is empty, right? Empty because it's HTML. And what I'm going to show you this underscore format. Now, what this is actually something that's built into Phoenix. My understanding, it came about when Chris was building Phoenix. He just got sick of having to constantly set the header of the content type. So in controller zone plug, he created this shortcut underscore format, and we ended up just using it for LiveView Native. Hold on, what just happened here? Oh, what happened is that I did not do this. I did not actually tell it to use this. So there was no content delegation going on. All right. So I won't bore you with like trying to parse this, but it's right here. Like here's the text, hi, jax.ex. So this showed that in this case, it's rendering out the SwiftUI version of the template instead, right? All right. Now let's do the interesting part, which is showing the actual client. And I'm going to open up the native SwiftUI. And when we get the Jetpack client, and a good spot for everyone to start using, that will generate a Jetpack project into Native slash Jetpack, and then WinUI 3 to, so on and so forth.
Can I ask a quick question about that? The
Yep.
Jetpack? So,
Sure.
like you're using SwiftUI on the iOS side, is that going to be using Compose on the Android side?
Yeah, we have most of the client written already. I did a stream 2 weeks ago with the lead dev on it, and we built an application with the Jetpack client. It's definitely gotten less love than the primary kind of dog fooding on this has been the SwiftUI client. Um, Unfortunately, the Jetpack developer actually just left Dockyard. Um, he he's been kind of flying solo on the project for a long time, and my focus has been on the SwiftUI client. He, I think, wanted to work with people in person again. So he was a great developer, and we're still connected to him. And if things come up, we can ping him on it. But the focus for now is just to get the SwiftUI client as solid as possible, and then continue to like bring back a Jetpack developer. Probably, I think that's someone will be pursuing in early Q1 to complete the work on the Jetpack client. Okay, so here's a good example. If I zoom in, do you see the zoom in or no?
Yes.
Okay, so this is something we cannot control, unfortunately. When we generate the Xcode project, we use something called Xcode Gen, but we cannot set the default target of the project. So when we create an Xcode project, we create two targets. This one right here, you see like the square and the circle, make it a little bit easier.
Mhm.
The square one is called a multi-target project, and then the circle is just the watch. Apple does this because there are older versions of Apple Watch that require the companion application. And so they have Watch as this separate like sub project that requires its own target. And so everything else, every other device that we have is under this project right here. But when we generate the project, we cannot decide what the default is. And for whatever reason, more often than not, it always decides the default to watch. I don't know why. And so a lot of people have gotten tripped up over that. Just note that when you open up the project, just choose, just make sure it's not on watch. And then it's on my Mac. So I'm going to go over here and change it to iPhone 16 Pro. I'll go to 18.2. All right. So what you get in here now is a bunch of views. You go into the content view, and this is pretty much the heart of the application. You get this live view macro.
Right, can you bump this just a little bit?
Oh, yeah.
Thank you.
Yep. Let me just get my, hold on. My mouth is getting dry. You just get my drink. All right. So this here is just a SwiftUI view, but it also manages all the connection and rendering of LiveView Native. So what I'll show is I'll build the application. Actually, I should probably build it while I'm talking, because the first compilation always takes a bit of time. But we introduce a bunch of additional states. So because this is server-driven UI, we have to acknowledge that the server may not be available, or there may be some sort of latency that occurs, and we want to make sure that there are always views that are available on device that get defaulted to in certain cases. So if there's a disconnection, we render out this disconnected view. If the application is reconnecting for any reason, if the server goes down, it's reconnecting view. If there's an error view. And these are defined right in here. So you can go in and customize these as much as you want. The error view for development will show like the Phoenix stack trace. And then in production, it'll just show like a basic error message. And then reconnecting view will show a progress view somewhere in here. But in addition to that, up here, this is just another SwiftUI view, which means that you can actually build hybrid applications. So if you wanted to actually take an existing SwiftUI application and add LiveView Native to it, and say, hey, I have this part of my app where I'm like hitting an API and doing all this other stuff, but there's good reason for me to keep people on device. Right? There's going to be use cases where using LiveView Native is not the best solution. So we permit for hybrid apps because this is just, again, another view in SwiftUI. So you can mix it with other SwiftUI views. And this is always a part of the demo where I don't time it right because the build takes what it takes. I did it on, I was streaming one day on OBS and I didn't realize how many resources OBS uses on my system. And I was trying to compile for Apple Vision Pro. Oh, there it goes. Okay, I'll shut up. It was slow. And so I think streaming makes it a little bit slower sometimes.
Yes.
So this is still installing. If you can see that in the background, it takes a minute or two the first time. And then on additional compilations, it's significantly faster. Unless you add something into here. Oh, connection failed. Do I not running the server? Yeah, I'm not running the server.
The server set to example.com.
No. That's production. I wasn't running the local server.
Okay.
So there it is. Let me just close this one in the background. Okay. Hold on. I had another one open. Close that. Stop tasks. As long as Xcode doesn't mess with me. All right. So I'm going to put this one so it's always on top. Stay on top. And then I'll go in the background here. And we're going to go back here. So if anyone has done like native iOS development, every time you change your application, you have to recompile it, right? So with LiveView Native, we actually introduced live reload. So we can say right in here, and as soon as we save it, it refreshes right in there. So if we wanted to start getting a bit more, creative with it, we can just do a button here and say +1, button stack. Roll with that. Now we have a basic load button. I'm going to add some styling to this. So we're going to say foreground, I think tint actually, tint, and then do the blue. I think that's it. I'm not very good at this. Actually, I think it's already blue, right? Red. Okay, so now it's red. And then I'm going to say foreground color style dot blue. I didn't spell foreground properly. Hold on. This is where I start to go over to Claude. Okay, so if I go to Claude, and I say in Swift UI, how do I make a blue button? Tell me, Claude. All right, so, and we have a button. And it looks like it's foreground color dot yellow. No, it's showing background. Overlay capsule. I guess we'll just add some padding to it. All right, so if we go over here now, I did delete everything. I'll say padding 10. And so it added a little bit of padding there. If I put a spacer in between them, spacer will do, spacer basically pushes everything apart as much as possible, which we don't want in this case because that went too wide. But what we do want to do is now have some interactions. So I'm going to make another button and I'm going to actually create, I'm going to make this an H stack. So these buttons are right next to one another. I'm going to introduce a V stack. So the text is on top and this is going to be V stack here. All right. So those are right next to each other. And now we're going to do the count in here. Oh, am I on LiveView 1.0 or not? Is that gonna work? Okay, I think am I on LiveView? I might be on LiveView 1.0. So if people haven't been paying attention to the recent release of LiveView, it expanded curly braces throughout all like almost everywhere throughout the templates. So in up until like RC8, I think you had to do the EX syntax like this. And then the curly braces were reserved for within the attributes themselves. But now we can just do this, which is nice. All right, so we want this to be, let's make this one yellow. And this is going to say -1 here. And then we are going to do a PHX click and have this be increment. Oh, that's decrement, sorry. And then PHX click, have this be increment. All right, so now if I click on them, like we get the error, right? Because I don't have the event handlers set up. So the event handlers are defined back in the original LiveView because again, we share the state management. We share the event handling for the same LiveView. So if you have a pre-existing LiveView application that's fairly complex, the idea is that you have most of your native app already built. You have the state management done. You have the event handling done. Then you just need to write the templates to actually hook up and wire up those views. So we'll do handle event, and it was, I think the first one was decrement. This is no params. So we're going to do no reply, and then assign socket count socket dot assigns dot count -1. And then we'll do, all right, I'll do increment. And this will just be +1. So now if we do that, we see the count updating, incrementing and decrementing very easily. So this is a very kind of rudimentary introduction to building an application. But let's say, for example, leaning into that idea that we want to reutilize your pre-existing knowledge on building web applications, the style attribute here, very similar to the style attribute in the web. But instead of CSS rules, you're using modifiers, which is how Swift UI applications are done. But let's say you wanted to extract this out, right? So you don't want the color to be in the style. So you can also use classes. So we'll do red here and class equals yellow. So no styling yet because we haven't done it. This is where we go over to our style sheet here. So we're going to do red. And we're going to do tint red. And then we do yellow. And if we were to go and look at the back here, what we see is that in our markup, we have this style attribute, the style element, and this references our style sheet. So if we were to open this, localhost, this is going to include a bunch of stuff because it's also building styles off the core components themselves. But we can find that red is defined right here. And this, what ends up happening is that when the elements are being rendered into views in the client, it looks at that class, splits upon white space, and then looks up inside this dictionary in like maps or dictionaries in SwiftUI, key value pairs. And then this is effectively just an S expression, and it knows how to then apply this given modifier with the correct arguments, if arguments are given. In this case, it's the tint modifier, and the argument here is red. The middle is a just annotation data, so that if the modifiers crash or they don't apply for some reason, so I shouldn't say crash. if modifiers don't apply for some reason, they're being used and they're malformed or they don't make sense or they're not registered, then inside our actual in Xcode in this little tiny logger window, you're going to get a something like this here that shows. So, like for example, this one, I don't know why this navigation subtitle is being used because it's not. I think this one's been deprecated possibly, but it'll basically ignore and then continue, but report out something that didn't work. All right, so let's see here. I can introduce inside the core components. I think I have a button one, right? Let me see here what I got. So if I do, let's see here, def button here, and I'm going to introduce the, oh, that's a submit. I don't want submit. No, that's a very simple example. Let me see what something that might look a little better. Well, let's try modal. All right, so I actually not sure what's going to happen. I didn't plan to use modal, so let's see what it's going to look like. If I do, I'm going to add a button here. So this basically is a, it wants a conditional whether or not it's going to show the modal. So let's change this over to inside here. I'm going to do just a button now. And I'll do button, PHX click, and we're just going to call it modal. And then do modal. And then we're going to do modal here. And what was it? It was, I'll just copy this off of the documentation. All right, so we need to add this the show attribute because it's currently not it's not added. So we see the stack trace here. So we're going to just keep trying to do a live reload, but we need to add the I know we're saying show, but yeah, the show key is not found. So let's add that in. And we're going to change this to show, and we'll say false. All right, so this here is going to fail because we don't have the event handler set up. So let's go ahead and do that. We're going to get rid of this one. And I think I called it modal, right? Is it modal?
Toggle show.
What's that?
Oh, I thought it was like toggle show.
No. The PHX click event
Oh.
was modal.
Right.
And so we're going to do show here, and we'll change this to true. All right, let's see what happens. All right, modal. And so I brought up this. So not sure if you can tell, but this is a sheet here on it's you see that animation, but it's basically brought up a sheet, which is the kind of the iOS equivalent of what a modal would be. Not like alert dialog box. We can bring that back down. And when you brought it back down, it actually triggered another event. So I think it triggered a second event somewhere. Where was
I think
it?
it's toggle show, it looked
That's
like.
probably behind it. Yeah. So if we go back to the on cancel toggle show. So if we were to basically handle that event, we can then do whatever we want with the state, right? So that's the extent of just like a very simple application and how quickly we got native application up and running. I'm going to now pivot over to a significantly more complex application and show multi-device support. Actually, hold on. I'll show multi-device support before I go over to the more complex app. Right now, inside here, inside here. So this is rendering out for all devices. If I were to connect with tvOS, this would render out. If I were to connect to watchOS, this would render out. So if I then change this to, let's put this right here. And we're going to do target. iOS. And we'll do LVN. Text. Hello, iPhone. All right, so that renders right there, right? But if I change this to iPad OS, and then it goes back to the prior one. So we can match on specific targets. We can also now render out these render templates. So if I were to actually cut this out and put it inside here, just like an HTML template, right now it's not rendering because these render functions are already defined and they override the this right here. So if I remove this render function, now we get it back. In this case, is because we have a render function for iPad OS, and this is like a general render function here. So if we were to, we can actually introduce target specific templates too. So the name of this template right now is home_live.swiftui.neeks. So I'm going to rename it to home swiftui.ios. Sorry, plus iOS. And this allows us to keep it as now it's an iOS specific template. If I were to rename this to watchOS, this will error because it doesn't have a render, like a matching render function at this point. And so this allows us to do a lot of like really complex application builds that really like target specific UIs per device. So one thing that we're introducing in the next version of LiveView Native is if I wanted to have a specific text that was I don't know, like I'll say this. So this is now just again a general SwiftUI template. Now, if I say hi SwiftUI, what we have already introduced is a new special attribute called interface dash. And similar on the web where you have the data attribute, you have data dash whatever. Like whatever comes after the dash is now like the key that you're really going off of. And then equals is the value. In this case, we can key off of anything that's included in the interface object. So we can do target here and then do like watchOS or I don't know, tvOS. This is going to crash right now because this version of LiveView Native doesn't understand this special attribute. And so this is just, oh, actually we ran into another thing. So the 031, this is already fixed on main. So the version that will come out on Wednesday has this fixed. But we found this is like a really embarrassing bug, is live reload continues to append the format and interface query params on. It doesn't replace. And so at some point the URI just becomes too long and it crashes the 031 client. So I just have to cycle this out. All right, so now this will bomb because it doesn't understand this, but this is currently working on main. But I wanted to show that we are introducing multiple ways to give device-specific rendering, or even like any type of values that are in that target interface. So let's take a look at that interface value real quick. If I come back into here, and let's do a kind of a greedy matcher on this. And so what we have currently in the interface that you can match upon, the app build version, the app version, bundle ID, internationalization information, localization information, the operating system, in this case iOS, the operating system version 18.2, and then the target, which is iOS. So the thing with native development that's very different than web is on the web, when we make a change, we can distribute that full client out immediately, and then we can force a reload of the application and people get the latest updates. With native, we don't have a guarantee. Like if there's a new version of LiveView Native that comes out, or if you want to include a new add-on, you have to recompile the application, put it back on the App Store. You don't have a guarantee that every one of your clients has that latest version. And so you're going to need some guardrails to actually match against and have some alternative templates in order to account for those potential differences that are out there or other clients. Or you could even have a like a primary matcher that matches your current like good production version, and anybody else that is not on the latest, you can have it default back to a greeting matcher that says, hey, like go update your application, right? Just to tell them to go ahead and go and do that, just so that they aren't trying to render out a template that includes views or access to things that is not included in the compiled client. All right. Okay, so now let's go over to a more complex example. And if people watch him on the YouTubes, there is a it's not the Alexa version. So his name's he's Theo. People have probably heard about him. He's a YouTube influencer, and he's also I don't call him a former Elixir developer, but he definitely is no longer working Elixir as his primary stack. But he used to work on it quite a bit in Twitch, and he was also the keynote speaker at ElixirConf this past year. So he did a video a couple weeks ago where he showed a comparison of different technology stacks, and just like a non-trivial application, or still kind of a trivial application. It was like a Pokemon battle app, right? So it was it shows two Pokemon images, and then you choose which one you like, and then it would have a results table. So I took his Elixir app, and me being me, I was like, oh, I'll use this as an opportunity to promote my own thing. And so I've been building out a good-looking LiveView Native versions of his application around it. So we're going to open up the native app here and close this one down. And then I will start the server. And I will do I still have the other one open? Which one's this? That's the demo one. I'm going to close that. And then that's on, we're not going to go to the Apple Vision just yet. We're going to change this over to my iPhone, and we'll run the simulator. So I'm going to show the iPhone version, and tvOS version, and Apple Watch version, which I actually think is the coolest one I did because I put a lot of time in to make it really nice. And then Apple Vision Pro. iPad is not a very compelling one to show because it's just like a wider iPhone. And then Mac OS, you can do them, but it's very much like the redheaded stepchild of Swift UI development. It's fine, it works, but everything looks much better on their like iOS variant devices. Okay, while this is compiling, this is always a good opportunity for questions if people have them while we're waiting, because the compilation aspect is always the unfortunate part of these demos.
I have a couple questions I was going to ask.
Sure.
So I've been doing iOS development for about 8 years.
Yeah.
And I had a question as far as like right now, how far back as far as iOS versions do you support? The current version is 18.2.
We go to, I think, 16. And that's mostly because there are, well, you should know, like every major iOS version, they make some pretty big changes, and we needed some things that didn't come about until 16. Well, actually, that's not true. We originally started on 14.5, I think. No, not 14.5, maybe 14 something, not 14.0, 14 something. But we had to do a lot of workarounds and some compromises. And 16, I believe, was the first version that we did not feel like we really had to compromise. I couldn't specifically tell you what those compromises were. The lead developer, Carson, let's see what this is here. Hold on. I have Reality Kit included. Let me just, this is actually, we need to fix this because like if we have Reality Kit included, it doesn't compile for other devices. We should be able to compile it, but it currently won't. And I think that's it. Yeah. Okay. And it does the same thing for like watchOS at the moment with Liveform. So we just have to like in Swift, you can put in these basically checks against the device target and then the version to ensure that you're compiling against it properly, or ignoring it, in other words, or taking it out of the compilation if it's not if it doesn't work for that given library. And we just don't have those workarounds in Reality Kit yet. So I had last shown this with Apple Vision Pro, and and clearly the build failed because I'm trying to build for iPhone at the moment. Oh, I forgot to remove it here.
Mm.
All right. Yeah, that's fine actually. Just make sure I don't have any more stupid things I forgot to take out. Well, actually, so you've been doing iOS development for a while. Why is it when I hit rebuild, it doesn't clear out the errors until the compilation is complete? Like, why not just like clear the error buffer?
My understanding is that they do a lot of kind of like pre-compilation. There's a lot of stuff where they try to, with Xcode, they actually try to compile or have like a compilation that happens as you type. So for instance, like you'll start getting like warnings and stuff like that. It's like a language server, but a little bit more elaborate. That's my understanding. And so I get the same thing in all my builds. It's like, I'll get these warnings and errors and stuff like that until it finishes going through the compilation step.
Yeah, it's not a big deal once you know it. It's like the first early on when I first started building the original prototype. I think my brain on the tech stacks I've always been in is once you restart the compilation, it's almost like a fresh start. And
Yeah.
here they stick around. Like, am I still wrong? And it took me a while just to say, all right, whatever, I'll just accept it.
A workaround for that is to just do a clean and a clear.
Yep. Yeah.
All errors. It'll do that.
That is something to bring up. In Xcode, you have to become accustomed to actually like doing clean builds periodically. Like your build state can just get in a weird, funky thing for whatever reason. The package management does not feel as robust as you would expect from a $3 trillion company. I discovered that they claim to observe SEMVer, but when it comes to release candidate like version tagging on version numbers, it doesn't actually respect SEMVer. So there's oddities to get used to. Anyway, so let me show like the web version of this first. So Pokemon Battle app, just pretty basic stuff here. And can I move this? So what Theo showed off was this, and I don't know if you can see it on the video, but there's a slight like latency on the image showing. Like if I jam these pretty good, like you can see it on my machine. I don't know again if it's coming through on the video or not. So we created a turbo version, which was a pretty clever implementation because it will pre-render the next two images, and they're just like opacity hidden or display none rather. And with like asset caching, it has a cache header, and so when those images now, after you vote, those images have already been downloaded, and so they're instantly available. So it just feels a lot snappier. And then a results table, right? So pretty basic app. So we rebuilt this in iOS, including the turbo version. So here we go with like the voting, and I just didn't like so. These are asynchronous images, and asynchronous images in async image rather in SwiftUI has several different states. While the image is still coming in, there's like a pending or loading state, and then if it fails for whatever reason, there's an error state. And we account for this in our, so let me show that. I'm in it, def image. So our image core component actually renders out async image. And then we have the failure, success, and empty slots. And these match if you go into Swift UI, you're going to see, where's the phase one? So is it phase? It's one of these here that matches. That basically the phases of the async image, we just match off of that for the slot names effectively. So it can be a bit odd the first time you're doing it when if you were to look at a image here, so you don't put the styles on the image, on the async image element or on the image function component directly. You have to put it on the success slot because the image that you receive, if you want to style the image itself, is what's inside the success slot. The async image view is not the actual image. And this is the same thing within Swift UI. If you want to style the image that gets received after the asynchronous event has completed, then you actually have to style within the success phase, if that makes sense. And so that's why we see the styles here on the success slot. But so we have, and anyway, the reason why you see like some jank when I go really fast is because it's momentarily showing the empty slot. And I just haven't set up a frame for that to like have it take up the same space as the regular image. And that's just a like implementation detail that I can work around. So we have the, which one is it down here? It is the Poke results live Swift UI. And whoops, Poke results. No, that's not results. I want Poke live Swift UI. And we have a bunch of different so this is a good reason why that special attribute was introduced because these templates are almost identical with the exception of like 2 or 3 elements because it's different for watchOS versus tvOS, for example. But when I started building this out, I was like, oh, I'm just doing a lot of repetition. It'd be nice if I could just put in a conditional right here, conditional like special attribute and do that. So that's where that's coming from. But the iOS one is right here. And we just have a basic image right here for one side and then the other. So we implemented the turbo version identical to how he implemented the turbo version on web. So if I look at the preload Swift UI here, what we end up doing is that's not it. Preload Swift UI. So we do a Z stack, which stacks elements on top of one another. And we do the next 2 entries as basically opacity 0. So no 0 opacity underneath these images. So those next 2 images are already loaded. And the because SwiftUI is already loading them and they're technically in the view tree, that asset URL is now being cached and it's going to go like this is a lot snappier. So again, I don't know if that's coming through on the video or not, just with the streaming itself, but it's feels more native type experience. And then we went ahead and implemented the results table as well. So this is, I don't know how many are in here, but there's maybe 1,000 Pokemon. And our results implementation is fairly, oh, it's up here. There's a separate template. So it's just a table and that's effectively the whole view right there to render all this out. And this isn't even built in probably the most idiomatic way for iOS because you have so many elements in here. You want to use what's more of a lazy, a lazy loading. And this would probably be better implemented as a lazy VStack or some sort of lazy scroll view. but this still works pretty well, and it loaded like really fast. So if I were to go back to the voting and then go back to the results here, like it renders like super, super fast. Now this is local, but if I were to deploy it, the render aspect of it is not the the big hang up. And we have roughly I don't know what the actual like time is on the transition there, but it's probably about half a second, and that's more than enough time to get the template and to get everything rendered in. So the feeling of native is there, the performance of native is there, access to everything on the device is there, and so on and so forth. So let's show another device now. I'll go with tvOS. So we're gonna go out of here, and I closed the app. I shouldn't have closed the app because it caused it to bomb out. But we'll go to Apple TV, and I'll go to this one, and we'll do compilation. And for the Apple Vision Pro one, I got my Apple Vision Pro right here. I'll show off LVN Go with it, and I'll actually mirror my Apple Vision Pro to my laptop so that you can see me actually use it on device. I think it's a bit more interesting at times seeing, especially the Apple Vision Pro. I like it for productivity because I can actually mirror my desktop to it and I can actually like work off of it, although it's super heavy and I can only last about 90 minutes. Hopefully they'll improve that eventually. But showing off demos on it looks pretty cool. Definitely cooler than doing it in the simulator.
Are there any, has anyone deployed any production apps to the App Store with LiveView Native?
There's the Lax app. We have LVN Go is in there for I think the better question is, has anyone done like a production application that is like super useful making money? The answer is no. It's pretty early. We just did the first release 03 that I said was ready, for people to start using because the fundamentals are in place. And now it's all about UI improvements and just bug squashing. But adoption has been slow, and I think that is in part because a lot of people have voiced this desire of having Jetpack there. Like the value proposition of LiveView Native of building it out for all different devices doesn't work without Jetpack, I think. So
I guess
people have been waiting on that.
the hidden question in there is, and I don't know hardly anything about iOS development, but have you guys been able to get through the App Store
Oh,
review?
yes. Okay, yeah. The answer is yes. And the so the idea around the App Store is that Apple, is in charge of approving what gets into the App Store. And Apple has very specific rules about not permitting why'd this fail here? I'll get to that in a second. Apple has very specific rules about not permitting remote code execution. And there have been several examples of this over time where I think the most famous one was actually DJI. One of their app releases had this library in it called JS Patch. And so you installed their application on your phone, and then JS Patch was hot code loading, like actual updates to itself and recompiling itself on the fly. And Apple said no, and they kicked DJI out of the App Store for a period of time, and they banned JS Patch. So what we are doing is not considered hot code loading or doing remote code execution. We do not we do not send actual code from the server to execute on the client. We are simply sending an actual like view tree representation that is already predefined on the client. So only views that we have actually registered with the client get accessed. Only modifiers that we have registered on the client are accessible. Let me just see what's going on with this real quick. Why is it bombing? Just see what's happening. Key link name not found in. Oh, did I screw something up? I think I may have screwed something up. All right, let me just get the tvOS one because I think that was actually something I was messing with before, and I don't really feel like going into debug mode at the moment. So I'm gonna go over to the watch one because that one is totally fine. Okay, so now I have to go over to this project and over here. So the server, and then start here. So the watchOS one is my favorite one because we probably spent the most time making it look really nice, but also it kind of pushed like my knowledge forward on building native apps. Whereas most of my professional experience has been in the web side of things and knowing all the tricks to make applications look and perform well on the web. Yeah, this introduced some kind of cool tricks you can use to make native applications look really nice. I'll show those off in a second. And actually, what I'll do in the meantime is show off the LVN Go application. So I'm connecting to my phone right now, which is right next to me, with what's called LVN Go. And LVN Go is a pre-built application that, so I have to grab the phone for a second real quick. So we have this kind of way to force the LVN Go application to go back to its like start position, and you shake the phone and it brings up this little quick actions menu. I'm gonna do disconnect here, and then I'm gonna connect to I think it's this address, maybe. Hold on, what's my local address? Come back here, disconnect. May have to look it up. All right, hold on, let me get my local address. It is oh 192.69. Okay. All right, all of our power went off last night and it rebooted my router. And I think all my devices got reassigned new IP addresses. Okay, shake. I'll just restart it. Do this. I'll just open it up here. And go. Okay. Close that. Connect. All right, so this was 192.168.6.9 4000. All right, so this allows you to basically avoid having to compile Xcode every single time. And then connect to applications locally. We have LVN Go built for iPhone, iPad, Mac OS, Vision Pro. We just got rejected from the App Store for tvOS because I think they said they couldn't connect to anything. I think that Fly was having an issue on like our cookbook application, which I'll show off in a few minutes. The downside with the currently released version, the 0.3.1 version of LVN Go, you'll see this on the navigation. So you see that like white little janky blip there. That's because in our compiled application, we were able to where's it, connecting view? Yeah, so we're able to change the connecting view, which is in the app, to basically be the same background as the rest of the application. And this is something that we're introducing in the next version, where in our navigation links, we can define a subtemplate that will then put into place for the connecting view instead. So all from the server, you can now override all of these kind of pre-compiled things that are there as a default, and then you can have overrides from the server itself. so that you can have a more customized experience that feels more native. But this here, works just fine. I'll go to the turbo version and, pretty performant. This is working over network right now. Okay, so let's go over to the watchOS version. All right, so if I zoom in, this is showing it, right? You're zoomed in now too?
Yeah.
Okay. All right. So we have like the voting here. And again, you can see like we're showing that little message cancel. That's the async image thing I didn't account for. If we go over the turbo version, nice and fast, pretty fast. My favorite thing though is the results. So we wanted the results to look like Pokemon cards. And so we actually, if you see the digital crown right there, I'm gonna zoom in like really far. This is kind of funny that they did this, but if I go over the digital crown and I actually like use my my touchpad, you can see the digital crown like moving, and we use the digital crown to actually cycle through each individual card. So we can go like super fast and go through them, and go to each one individually. It will show the image. It will show like it's. I think you have to go pretty far down. Okay, so this is starting. Yes. Oh, is that a asynchronous thing? Yeah. So I wonder where that image is. Those images are supposed to be downloaded on the server, and maybe I didn't download all of them. It's probably, yeah, they're probably just bad images that didn't come down. Um, so this is a gauge element that's pretty simple. If I go back over to here, and if I were to go to the watchOS template. So this is the results right here. It's 46 lines, but we have this gauge element, and this is a built-in SwiftUI thing. There's not much to it. I just say the value that it currently is, and we put like that 80% in there, and then we put the number of votes at the bottom. We give it the color. We put them next to each other, and SwiftUI just makes it look nice. That's the really great thing about SwiftUI is that because it's Apple's ecosystem, you're gonna be able to make like beautiful looking applications very, very easily. It just takes some time to understand that building on SwiftUI, building in Jetpack is kind of like a mental model that's different than the web. Like we're so accustomed to the box model, we're so accustomed to all the quirks on the browser that it's just a different way of thinking about how to build applications that you have to start learning to a degree. But a nice trick that we did here was so like each background is kind of a average color for the images themselves. And well, not that one because that didn't load. The way we accomplished that was for where is it? Okay, so this image function component is the actual image you're seeing. This one here is the exact same image, but what we do is we make it behind the this image here, so it's underneath it. But then we set it to be gigantic, and then we just set a huge blur radius. And this just blurs the image and gives it kind of like an average color across its base. And it's a nice little trick to give you like that kind of really good looking effect. And then we can navigate back to the votes individually, and then continue voting if we wanted to. Okay, so let's go over to Apple Vision Pro, and I'm just going to take off my headphones because I can't do both at the same time. So I'm going to unplug this. And if I look stupid doing this, that's all right. It's kind of just the Apple Vision Pro. So let me first check my battery. 99. Okay. And I'm going to mirror to my laptop. Okay. So can you guys see that or no?
Yeah.
Yeah.
Hmm. Hold on, I don't think it's taken my audio. All right. Select the speaker. Okay. Can you guys talk? Can I hear you now?
Yes.
Okay. So did you guys see when I did the mirroring a minute ago?
We do.
Yeah.
Yeah.
You did? Okay. All right. I'll go back to it. All right. So I'm going to go over to my LVN Go app on here. And I am going to put in a new one here. Can I use my keyboard for this? No, I can't. All right, I gotta enter everything. 192.168.6.9 colon 4,000. Turn and launch. Launch. Did I enter that right? Come on. Okay, guess not. Maybe you have to put the HTTP before it. Oh, I didn't want to do that. Damn it. This is not the best way to. Okay, I can just type on it, right? HTTP.
There you go.
Yep. Colon. Where's my slash? Not that one. Where's the other slash?
Is the infinite virtual
Oh, there we
space.
go. Slash. 192.168.6. That's not right. 6.9 colon 4,000. Turn. Launch. Okay, allow. Okay, so now I have my Pokemon Go app. Oh, hold on. You know what? I don't have Reality Kit built for it. That's right. I mean, it's gonna launch, but it's gonna do the iPad version. We need so Reality Kit is unreleased yet. We don't like it's working, but it's personally implemented. We don't have it released yet, so this is just like a boring version of it. I should have noticed that. All right, so we'll pull this out for a second. I'm going to show you the spatial version of it then. I'll just bring back Reality Kit into the actual build. And then that's pretty much going to wrap things up. So we're going to kill the simulator, move you guys over here, and then I'm going to start uncommenting things. So I'm going to go back into here and bring back our Reality Kit, my local version, not released. Yes. And then make sure that it's in here. Where is it? Reality Kit, add. And then up here, uncomment here. And then this and here. Okay. I could compile it and then actually send it to my device. But compiling for Apple Vision Pro is a bit dodgy still. I have the developer strap, which was like $300 for this little dongle, because without it, it can sometimes take like an hour to actually compile there. And even with the developer strap, it's still like hit or miss, unfortunately. But Reality Kit allows us to create an immersive space. and we can actually interact with the environment. The nice thing with it is that it's all just Swift UI. And so these are Swift UI views again. And because they're Swift UI views, we can wrap them and we can represent them in LiveView Native markup. So if I were to come over here and look at the, which one was it? It was not preload. This one. No, not results. It was Poke Live. And if I go to Vision OS, so we have a reality view. We have these entities that are our first entry, second entry. So these are our kind of IDs to the images. And then we have the attachment on the first entry, and that allows us to style it up. And then we have attachment on the second entry, allows us to style it up. And it's in a reality view. And reality view is just a 3D plane. So let's see how this is doing. Okay, it's launching. There it goes. It should be attaching still.
Well, it's loading up. I was going to ask another question.
Sure, go ahead.
So, with all the different Swift UI elements that's in their SDK, there's all kinds of different modifiers and all that you can call or kind of customize. One of the things I was noticing about the way that you're building out your Swift UI components is it looks like you're using the attributes in place of those modifiers. And I was just curious, like, how many of the modifiers are you actually supporting?
Nearly all of them. So Swift UI is closed source, as I'm sure you're aware.
Yeah.
And there are, I believe, hundreds of modifiers in Swift UI. And so what Carson did was when you compile a Swift UI application, there are build artifacts along the way. One of the build artifacts was one we could actually parse all of the modifiers out of. And we use that to basically code gen the modifiers into LiveView Native. So if you go to Hex and you were to look up the SwiftUI library, you have to go to our 3.1 release. I screwed up the documentation. But if you go here, we have these are all the modifiers that we support. And they're all documented. And so it's going to show you the arguments and everything you can pass into it. Carson did an awesome job with making sure that our documentation, implies everything that we can do. We support animations, we support gestures. Right here, gestures are how you do pinch, zoom, all those type of effects. Let me just see here. I always forget the controls for doing. How do we get into it? Maybe this one? Oh, there we go. Okay. Well, where's this? You can go walk around the house. All right, let's go back here. All right, so I'm going to go up here. And then I'll go off the screen. All right, I'll go up here maybe. Nope, not that one. This one. Yeah, okay. I'll get a little bit closer. Not that one. This one. Okay. All right. Anyway, this is in a 3D space, right? And so if we can walk around it. Actually, what happens if we go to the back of it? If I go right past it, go back over here and spin it around. I guess they're just reversed. All right. I'll come back to it. Can I hit the buttons from behind it? I guess I can't touch the buttons from behind. Interesting. All right. So let me come back. And it's not the most like the best example in here, but oh, maybe because I had the wrong interaction on. So I haven't implemented anything for this other than just the basic voting, but it shows that we can actually put these into a 3D space. We could load in models as well. These are just sprites. And so what I was looking to do is actually take the sprite and then extrude that out so you get like a semi 3D shape from it. But I decided not to take it that far. But like there's lots of possibilities with LiveView Native, and the more devices that Apple adds, as long as it's using Swift UI, we should be able to target it. For Jetpack, I believe that we are currently compiling for phone and tablet on the Android ecosystem, but just today, Android, this just dropped. So it's like the Android VR AR headset API, and they are building it for, they're going to have Jetpack Compose in it. So that at least gives us the possibility of compiling for augmented reality, virtual reality headsets in Android's ecosystem at some point in the near future. So that's kind of it. The project is at LiveView Native on GitHub if you want to check it out. Oh, actually, I should probably show one more thing. We have this thing called the cookbook. If you go to cookbook.liveviewnative.dev, you can go here on your phone. You can go here, like if this is on the screen right now. So people have like an iOS, like an iPhone. Go ahead and just scan that QR code with your phone. I'll give you a minute, and then we actually have app clips implemented. So if you scan the QR code with your phone, with an iPhone rather, not an Android. But if you scan with an iPhone, it will open up an app clip and then it'll immediately launch LiveView Native Go into our cookbook. And the cookbook is a collection of recipes that are like basic UI examples. So I don't know if anybody did it, but I'm going to just, oh, I'll go back in for you. Did it launch?
No.
You could also go to cookbook.liveviewnative.dev. So what I'll do is I'll launch the cookbook on my phone so you can see it. So if I go to iPhone mirroring and come back here and I'll do disconnect. And I'm going to go to the cookbook here. So this gives a bunch of examples on different like UI things. So we have, I forgot I have to use my touch. I can't use like mouse. We have Swift charts wrapped as well. This is a fairly basic charting example. We have gestures. So well, that's not gesture. Gesture is here. Can I do this on my, I don't know if I can do this on the mirroring or not, but I can do the drag certainly. So we have drag events, magnifying. I guess that works. So I'm just like doing a magnifying like outward. Can I do an inward pinch? Yes, I can. And rotate.
So this is all running
On
as
LiveView Native.
LiveView Native.
Yeah, yeah. So the repo is actually here. If you were to take a look at it, you can take a look at the cookbook. You can come in here, web, live, recipes. So if you're to look at the gesture one, that's just gesture right there. So these are the modifiers that are being used. We have fill red, frame, the offsets. Then we have this animation modifier, and then the gesture modifier, and it's just using the drag gesture. And then for the second one, which is magnify with magnify gesture and then rotate gesture. And these are effectively how you would write in Swift UI, just in a different style. You write it as chaining off of the view itself. Here, we take each of the individual modifiers and we just represent them as single styles. The other ones we have map kit almost entirely wrapped. So you know about map kit, we can zoom in, We can go to Street View on MapKit, and this is all in LiveView Native. Um, the well, AV kit. So this is video. I don't know if you hear the audio or not through the through it, but it's playing Big Buck Bunny, which is a Creative Commons video. We get all the video controls on it. And then this is just primarily meant to show like different UI patterns that are common in iOS. And if you want to say like, oh, I like this, like, how do I do this? And then you would just come here and you go to the onboarding one. And is it probably onboarding this one right here? And you just take a look at the template. You can say, hey, this is how I do it. So this, like, one thing I've always liked about the web versus native is that how open the web is. And if there's a website that has a nice pattern, I can just go take a look at it and say, yeah, that's how I'm going to take that and steal it. You lose that with native, right? There's actually I have found it as an open source web developer frustrating working in the native environment because there's not a lot of great documentation on doing these things, especially when you get into some of Apple's less popular devices. Like there's a lot of information out there on how to build out applications for phone. But when it comes to building out like a good looking tvOS app, there actually isn't a lot of information out there on that. And so something like LiveView Native, if you have a LiveView Native application, I can come here and I can just take a look at the actual implementation of it. So this kind of democratizes the event, not to say that everyone's going to be using this, but people that do and end up using it, you can learn from each other pretty easily and actually see how these UIs are built, what their modifiers that they're using. Because the entire modifier system is so deep. And one thing that really tripped us up when building, so when I first built the product, like the very first prototype I built for LiveView Native, I built it in about I'd never written Swift before. I had like barely years ago, but I sat down and I said, okay, I'm gonna just take like the client proxy in LiveView. I'm gonna re-implement it in Swift, and then it took like maybe a month or two. It started working, and then I went to ElixirConf and presented it, and I said 3 months until this is done, but like what ended up being like the real time killer was the modifiers, because we're like, okay, we're gonna make the modifiers just attributes on the element. But modifiers are not like CSS styles in that CSS styles are just like individual rules. Modifiers can be infinitely nested. And modifiers can take other views as arguments, and those views can have their own modifiers, and so on and so forth. Whereas in CSS, you don't have a CSS rule that takes HTML. So how do we represent that properly? I have a whole blog post written on doing just that. It's is it this one, or it might be actually be part 1.1. Is it on templates? Yeah. So actually, is this one? Yeah. So if you go through the Dockyard blog and you look for these blog posts, like create your first LiveView Native app, I haven't put out the third part yet because of the navigation issues that we were running into with the jank. And I just want to show that real quick. So if I come here and it's, where is it? Oh, this. Okay. So if we come here, so this is the prior like navigation. You can see what ends up happening. See how it gets pushed down? Like it's happening pretty quick, but I slow it down a bit. So you can see we navigate over and well, that's kind of crappy. But like it comes in and then that back button like disappears and everything kind of like pops up. The reason that this happens is that those are called navigation titles on navigation events in SwiftUI. The body of the page of the view that you're sliding in during the navigation event can be updated in flight. So while the animation is happening, we render the body from the next page that we fetch from LiveView Native on the server, and that gets in. The body renders just fine. The navigation title, though, is static until the navigation event completes. And so when we were navigating over, we didn't have the title of the next page until the next page was available. And so that navigation title is empty. And so the body is pushed up, the animation completes, and then the navigation title gets rendered in and it pops everything down, right? That's bad. And so we recently solved this, and we have we're going to be sharing details on how we did it, but this is like how it works on main now, and it's identical to the native experience. And the solution there was actually allowing for the navigation link itself to take a sub template where we have to know what the title of the next thing is, and we just set that on the effectively like the preload state. And then when the new view comes in, as long as you're not changing the title out, it's just going to look identical. Like you don't see any jank there. So these are like small little things that we're now just kind of like knocking off our list at this point to make the experience as native-like as possible. So that's it. That's the presentation. That's the progress in LiveView Native. It'd be great, especially people that have experience building out native applications before, to get their perspective on it. See the areas that are working really well. Like, let us know about what sucks, what doesn't work well. I don't tell me my stuff sucks. I don't care. I want to know because I want the free QA. And we want to be able to fix this stuff because we're confident that we can actually deliver the best native experience, or as good a native experience as you're going to do on SwiftUI, but do it in a way with server-driven UI, so you get all the benefits of multi-device support, state management, event handling that is much nicer to do on LiveView. So thank you.
Thanks, Brian.
Thanks.
Thank you. I had a quick question, and I guess comparing LiveView Web with native, you showed an example earlier where I think it was the turbo option.
Yeah.
It was like loading the images in advance, take 2 images out, and I think you said that they were hitting with like opacity 0.
Yeah.
So my question is, if you have conditional rendering logic in SwiftUI, do you always do it like via opacity, or do you actually do conditional rendering where, like, if something in assigns is changed, now render or don't render that thing, like actually change the
view
in the view?
Yeah, I mean, you could do either. It really comes down to your use case. There are so in SwiftUI itself, like the way there's nothing in the web. You can use display none because it actually hides the thing, and it also takes it out of the flow of like the document. But that concept doesn't exist in SwiftUI. So we had to stack it as a Z stack so it didn't interrupt the flow of like the top part of the Z index. A good example of this, a better example of this rather, is that let's imagine we have a list of items, right? And in on the web, if we have like a UL element and a bunch of LIs inside of it, we make one of the LIs display none. The DOM will collapse it so it doesn't look like if you have like 5 and you make the middle one display none, it'll just collapse it and it looks like there's really 4. In SwiftUI, if you were to set that middle one to opacity 0, there would be a gap. And even if you were to set the frame to 0, there'd still be that gap. So in SwiftUI, you don't use that trick necessarily to take things out of the flow. You just conditionally just don't render that particular item, and then the view tree automatically updates, and it works that way. What we wanted to do in this case was preload the image asset so it was cached. So when it gets loaded up on the next view, after you vote, it preloads the next 2, and then you vote and shows those next 2 immediately because it's just serving from the cache at that point instead of doing the asynchronous fetching. So it just looks snappier, and gives a better kind of native like experience. And again, that was a trick we borrowed from Theo's implementation. Um, and there's probably a argument to be made on supporting something like an asset manifest, where you could, when you launch the application, it does the work of going out and fetching a bunch of things already, just so they're already pre-cached, so that the application's snappy throughout. But in this case, that application has something like 1,000 images. So I don't know if it makes sense to have like going out and fetching 1,000 images for an asset manifest. But in some other, like a more reasonable application, you could have images that are throughout your app that you may want to preload just so that they're available and it gets that more kind of native like experience. So these are the type of optimizations that we're already starting to think about. Um, the Today I paired with somebody that wanted to do like microphone access. We didn't complete it, but microphone access is an AV foundation. And so the idea there is, or the common questions we get is like, how do we access the instruments on the device? What do we do with that, and how do we work with it? The answer is like, how would you do microphone access through LiveView on the web? You would drop down to the JavaScript, you access the microphone, and then whatever you're capturing from the microphone, you may push back to the server with like live upload, or if you record the whole thing and you then get the MP3 or whatever the format of the audio file is, you can even issue a post to an endpoint and post the data there, and then um, uh, within the Phoenix server, you can now do a pub sub event and then notify your live view based upon a unique ID that we've just received this asset, and like here's a URL to it, and then update your live view and update the state. And now that state's already updated, and like the new view is rendering properly within your native client. So there's different kind of strategies here on doing this. There's a lot of exploration that we've had to do, like thinking about what is the proper way to do this. Like we're effectively, like, not that we're super innovators, but we're developing a new method for server-driven UI that I don't think anyone's done before. There are examples of server-driven UI from big enterprise companies, but I think that there's never been a formalized framework in this way for native application development that I've seen. And so most of the patterns that we've been developing are, as far as I know, the first time exploring the space. So in most cases, I've been trying to lean more towards, okay, how do we do it on the web? And does it make sense to represent something like this in native? In the cases where it doesn't, we deviate away from it. And the reasons to do so is always for experience. So we don't want to be doing something the web way. We don't want to be always leaning into server-driven UI if it hurts the experience on device and takes you out of that mental idea that you're using something native. So like drag and drop is a great example, right? You don't want if you're dragging something around, you don't want the position of that thing controlled by the server. That should be a purely client-side thing. But when you drop it, then it should report to the server its XY position, and then whatever state you need to update on the server at that point to update the views is fair game. But there's just no getting around network latency. So if you find yourself kind of thinking too much about doing server-driven UI, and it's impacting the performance of your client-side experience, then I always tell people, like, look, LiveView is not a server-side rendered framework. It tries to straddle both worlds. I think a lot of people have the misconception that LiveView is meant to be purely server-driven, and it's not. Like, I was there when Chris created it. It happened at Dockyard, and that was always a goal, like from the beginning. And it's been probably one of the more frustrating parts of the JS community that they dismiss LiveView as, oh, we already know that doesn't work because we know there's lots of good cases where server-side rendering just doesn't make sense. And that's true. They're correct. But again, LiveView is not, it doesn't put stock completely in server-side rendering. Neither does LiveView Native. So there's going to be cases where you got to drop into the native language on that framework. There's going to be times that you're going to have to be writing Swift. There's going to be times you're going to have to be writing Kotlin. Our goal for LiveView Native is to try to reduce that as much as possible. So that's why we're starting to wrap more of the Apple libraries and exposing this in ways where perhaps you're going to be doing interactions with those things you'd otherwise be writing Swift code with as events. So we can push events from the server to the client. And the client, we can register events, listen for them, and then have certain things happen. So that's kind of the future of where we're looking to push towards. And we're more or less chasing the use cases at the moment. So when people like we have a client starting up in early January, and one of the things that they really need is like streaming video. So we are in the midst of wrapping PhotoKit so we can get access to the camera properly and then use live upload to stream that video back to the server. So it's, kind of first come, first serve effectively on what libraries get wrapped at the moment, priority order. Anything else? All right. Well, thank you very much for your time. I appreciate it. Sorry I couldn't be in there in person. And if anybody has any questions, head into the LiveView Native channel on Slack. I'm in there quite a bit. Always happy to help out. And, HashRocket being another shop, I don't care. If you guys start using LiveView